Good morning, my dear students. Our chapter number 5 is going on, which is electric current. In this chapter, we have studied Ohm's law, and yesterday we have studied derivation of Ohm's law, some small definitions like resistivity, electric resistance, ohmic, anomic resistance, conductance, and conductivity. Okay. Today we discuss about carbon resistance. Carbon resistance and color codes for carbon resistance. Our topic is carbon resistance and that device which is generate the resistance in a electric circuit is known as resistor. This device is known as resistor. So resistors are two types. First is wire bound resistor and another one is carbon resistor. Okay, first type of resistor, wire bound resistor. These are made by mixed metal like nichrome, manganese, and constant, and like this. And these resistors have a very low range. It means these resistors have very low value of resistance, and for high value we study carbon resistance. So we can say carbon resistors have high range, means high value of resistance. Okay, carbon resistance, a cylindrical shape like this. Carbon resistors have cylindrical shape. These are the conducting wire, and carbon resistors have four colored rings on its surface like this. Four colored coaxial rings like this. In these rings, first two ring, this is first, this second, this third, and this fourth. First two rings represent the first two digit, means figures. Okay, and third ring represent the multiplier, and fourth ring represent the tolerance of a resistor. This represent the tolerance of a resistor. Okay, but in a special condition, if fourth ring is absent on this surface, then that indicates that here no color. It means this ring represents the no color of a ring. Okay, for this we have to remember a table which is follows as. We remember a table and a simple trick we learn for this table. First column represent the color, second is number or figure or digit, and third is multiplier, and fourth tolerance. Okay, a simple trick for this table, which is black, brown, road of your gate become very good when given silver color. This is a very simple trick for this table. Black brown road of your gate become very good when given silver color. From this trick we can write first is black, second brown, third R. R is the red, of it means orange. From your yellow, from gate green, from become blue, and from very violet, and from good gray, and from when white, from a given golden, from silver, and from color, this is indicate the no color. Okay, this is very simple trick. Now we write number of these colors. For black 0, 1, 2, 3, 4, 5, 6, 7, 8, and for white 9 number. Multiply, it is represent multiply of 10 to power 0, 1, 10 to power 2, 10 to power 3, and 4, and 5, 6, 10 to power 7, 10 to power 8, 10 to power 9. Okay, and for golden 10 to power minus 1, for silver 10 to power minus 2. Okay, and tolerance of a golden silver no color is plus minus 5%, plus minus 10%, and plus minus 20% respectively. This is the table for find out the resistance of carbon resistor. Okay, and for this table we learn a simple trick. Black brown road of your gate become very good when given silver color. Okay, from this trick we have learned this table. Simply number of these colors is start from 0 to 9 and multiply 10 to power 0 to 10 to power 9 and 10 to power minus 1, 10 to power minus 2, and tolerance plus minus 5% for golden, plus minus 10% for silver, and plus minus 20% for a no color. Okay, now we take some example. Okay, suppose in question a diagram is given like that. Here four color rings are present like this. Okay, first represent the red color, second represent blue color, third ring is represent green color, and fourth represent the silver color. Okay, now determine the resistance of this resistor. This R is equals to first and second rings represent the number system number. So for red color the number is 2, for blue color number is 6. Multiply a multiplier of green color, this is for green color, 10 to power 5 ohm. and tolerance for silver color is plus minus 10%, so plus minus 10%. This is the resistance of this resistor. Okay, so such type of questions are asked in annual examination. This is very important. So another example, the value of carbon resistor is given like R is equals to 64 multiply 10 to power 2 ohm and tolerance plus minus 5%. Then write the color code in the order to it. So colors, first is 6 digit represent the color of blue, so first is blue. Second is 4 represent the yellow color, and third is multiply 10 to power 2 this is red color. Okay, and next plus minus 5%, this tolerance for a golden color, so this is golden. This is the answer for this question. Okay, so you practice about this type of questions. So for homework I give you a question. Find the resistance, value of resistance for this resistor. This is a resistor, and here 3 rings are present. First represent the color of green, second represent color of gray, and third represent color of orange. Then write the value of resistance for this resistor, and you write your answer in comment box. Okay, our next topic, this is effect of temperature on resistance and resistivity. Okay, first for conductor. For conductor, what is the effect of temperature on a resistance and resistivity? Okay, when we increase in the temperature, this temperature is increased, then the velocity of free electrons in this conductor will be increased. Then in this situation, the time taken to travel the distance between two consecutive collisions, which is denoted by relaxation time, is decreases. So we can say when we increase the temperature of conductor, then the value of relaxation time, which is denoted by tau, is decreases. Due to this, the resistivity is denoted by rho. Resistivity of conductor is increases, or we can say conductivity of a conductor is decreases. So we can say the resistivity of conductors increases when the temperature is increased for conductors. Okay, now we so dependency of the change in resistivity on the initial resistance and change in temperature. So the change in resistivity, so firstly we denote at 0 degrees centigrade resistivity is rho 0, and T degrees centigrade resistivity is rho T. Then change in resistivity, it means rho T minus rho 0 is directly proportional to initial resistivity, it means rho 0, and change in resistivity is directly proportional to a change in temperature. It means del T. Change in temperature del T is equals to T2 minus T1. From these equations, rho T minus rho 0 is directly proportional to rho naught rho 0 del T. If remove proportional sign, then rho T minus rho 0 is equals to alpha rho 0 del T. This is the proportional sign, but this is a constant alpha. Here alpha is the temperature coefficient of resistivity. Here alpha is the temperature coefficient of a resistivity. Okay, so from this equation, rho T is equals to rho 0 plus alpha rho 0 del T. Now we take rho 0 is common, so rho T is equals to rho 0 1 plus alpha del T. This equation is represent the dependency of resistivity on the temperature. Okay, here alpha is a temperature coefficient of resistivity, and value of alpha is equals to, from this equation, rho T minus rho 0 upon rho 0 del T. Rho T minus rho 0 is denote the change in resistivity, so del rho upon rho 0 into del T. This is the value of alpha, and from this equation we write the unit of alpha. So unit of alpha is unit of rho to unit of rho cancel out, then 1 upon temperature, and unit of temperature is Kelvin or degree centigrade. So unit of temperature coefficient of resistivity means alpha is 1 upon Kelvin or 1 upon degree centigrade. Okay, this is the a very important equation for our numerical questions, and this indicate the effect means dependency of temperature on resistivity. Similarly, we write the dependency of resistance on the temperature. Okay, and resistance is denoted by capital R. So capital RT according to this equation is equals to capital R no 0 1 plus alpha del T. This equation represents the dependency of a resistance on the temperature. These equations are very important for our numerical questions. Okay, from these equations, this equation we represent the dependency of resistivity on temperature by the graph. Okay, so graph between resistivity and temperature. At low temperature, for low temperature, graph is represented between the resistivity and temperature like this, and for high temperature, rho, this is T, this is at high temperature. This graph is represented by like this. Okay, so from this graph we see that if we increase in temperature, then resistivity of a conductor will be increased. Okay students, now if we take some another condition, if we initial temperature is T1, initial temperature is T1, and final temperature is T2, then in this situation rho T2 from this equation, and this equation, rho T2 is equals to rho T1 1 plus alpha del T time temperature interval, so denoted by T2 minus T1 like this. And for resistance, RT2 is equals to RT1 1 plus alpha T2 minus T1. This is the another form of a resistivity and resistance. This is the resistivity on T2 temperature. This is the resistivity on T1 temperature. 1 plus alpha is the temperature coefficient of resistivity. This is the final temperature and this is the initial temperature. Okay, this is the dependency of resistivity and resistance on the temperature for conductors. Now our second, for insulator and semiconductors. For insulator and semiconductors, okay, when we increase the temperature of insulator and semiconductors, if we increase the temperature of insulators and semiconductors, then the resistivity of insulators and semiconductor decreases exponentially. It means conductivity is increases exponentially. Okay, and this dependency are represented by this equation. This is rho t is equals to rho 0 exponential to power Eg upon 2 kBt. This equation is represent the resistivity at T temperature. Okay, here Eg is equals to energy gap between conduction band and valence band of a conductor and semiconductor and insulators. Okay, and Kb is represent the Boltzmann constant, and rho 0 is the initial resistivity, and T is temperature in Kelvin. T is temperature in a Kelvin, not degree centigrade, and rho T is the resistivity at T temperature. Okay, so you have learned this equation for our numerical question. From this equation we represent the graph between resistivity and temperature. Okay, so from this equation, at a high temperature, at low temperature, resistivity will be high, and we increase the temperature, then resistivity will be decreases exponentially like this. This is the graph of between resistivity and temperature of insulators and semiconductors. Okay, students. So you should this equation and this equation for our numerical questions. Okay, this is the effect of temperature on resistance and resistivity. Okay, students, if you like this video, then like it and write your answer of this question and feedback on comment box. And if you have any problem, then you write your problem in comment box. Thank you.